Hello everybody. One of the kinds of problems that we're going to run into in this section are the kind of problems where we're able to find exact values, and I'm talking about radicals and fractions, of angles like the sine of 75 degrees or the cosine of pi over 12. Now, to do that, I might note that 75 degrees, although that's not one of our common basic angles like the 30 or the 45 or 60 degree angle, we will note that 75 degrees does break apart into 45 degrees and 30 degrees as a sum, and that's actually useful to us because there is a way to use a formula to break apart this sum when it's an argument of the sine function. Same thing with cosine. Pi over 12 is the same thing as pi over 3 minus pi over 4, and I invite you to pause and check that out for yourself. But having a formula that we can use to break apart the argument would be a really useful thing. And in fact, there are. There are 6 of them. They go like this. For a sine of a sum, the sine of an angle u plus v, it will be the same as the sine of u times the cosine of v plus the cosine of u times the sine of v. So we don't just distribute, right? This is not multiplication, guys. This is the sine of a quantity u plus v, and we'll show that that is the same as the sine of u times the cosine of v plus the cosine of u times the sine of v. The sine of u minus v is going to be the sine of u times the cosine of v minus the cosine of u times the sine of v. Now it changes slightly when we have a cosine. If we want to take the cosine of a sum of two angles, u plus v, that's going to be the cosine of u times the cosine of v minus the sine of u times the sine of v. And similarly, if we take the cosine of a difference of two angles, u minus v, it'll be shown that it's the same as the cosine of u times the cosine of v plus the sine of u times the sine of v. Two other formulas right here. Of course, we could just take sine over cosine and get a tangent, but we can verify that this is also true, that if we took the tangent of u plus v, it would be the same as the tangent of u plus the tangent of v divided by 1 minus the product of tangent u times tangent v. And similarly, for the tangent of u minus v, we would take the tangent of u minus the tangent of v, divide that by 1 plus the tangent of u times the tangent of v. Now we'll take an opportunity and verify these identities here in a minute, but what I want to do is let's run through what happens, how these formulas are useful to us. And so let's do that with something like the sine of 75 degrees. So we're told to evaluate the sine of 75 degrees, and we might recognize that 75 degrees is the sum of 45 and 30. Since this is the sine of a sum, that means that what we should do here is go for our formula that says the sine of u plus v is the sine of u times the cosine of v plus the cosine of u times the sine of v. So in this case, what that means to us is that this quantity, sine of 45 degrees plus 30 degrees, will become the same thing as the sine of 45 degrees. That's a 45 degree. Trust me on that. So the sine of that 45 degrees times the cosine of the 30 degree angle added to the cosine of 45 degrees times the sine of the 30 degree angle. Now, you might want to think back, what were our exact values? Well, we remember the sine of 45 degrees was the same thing as the square root of 2 divided by 2. And the cosine of 30 degrees is the same thing as the square root of 3 divided by 2. Meanwhile, over here, the cosine of 45 degrees is also square root of 2 over 2, because the sine and the cosine for a 45 degree angle are equal, but the sine of 30 degrees is 1/2. Well, let's simplify that. Square root of 2 times the square root of 3 is the square root of 6, and we're dividing by 4. And of course, square root of 2 times 1 is just itself, divided by 4. And so our exact value for the sine of 75 degrees would be given by square root of 6 plus square root of 2 divided by 4, which is what we were looking for. All right, so that's the exact value. This is what the exact value of the sine of 75 degrees would actually look like, which is kind of cool. So let's talk about this cosine thing right here, right? The cosine of pi over 12, we're asked to evaluate that. And in this case, we can break apart pi over 12 as pi over 3 minus pi over 4. Now, to verify that, of course, we can see pi over 3 is the same thing as 3 pi over 12. Actually, my apologies, that's 4 pi over 12. I'm thinking about the angle that's next. All right, well, let's go back to it. 4 pi over 12 here. There we go. And of course, pi over 4, that's the one that's 3 pi over 12. And so we subtract those two. And we see that we're definitely going to get 1 pi over 12. All right, so that verifies the case. So cosine of A minus B, right? Cosine of U, here it is. This is that formula that we want to use. So we're going to go to this one right here and take the cosine of U minus V. Well, in this case, that means to us, we're going to be taking the cosine of the angle pi over 3 times the cosine of the angle pi over 4. And this time, we're going to subtract from it the sine of the angle pi over 3 and the sine of the angle pi over 4. That should be a 4 right here also. Okay, there we go. So what do we get? Well, cosine of pi over 3 we know is 1/2. We're multiplying that by the cosine of pi over 4, which we know from previously is square root of 2 divided by 2. Right? Might help to know your exact values. Sine of pi over 3 is radical 3 over 2. And then our sine of pi over 4 is the same as our cosine of pi over 4. That is the radical of 2 divided by 2. So, doing this multiplication and combining like terms, we're going to have the square root of 2 minus the square root of 6 over the common denominator 4, which is our exact value for this cosine. So there it is. Oh, sorry, one correction, right? Plus, I have to change sign, right? Let this be a lesson to you. Plus, plus, plus. Sort of interesting that it turns out to be plus. Why would the cosine of pi over 12 be the same thing as the sine of 75 degrees? Well, I'll let you figure that out. That's a good question for later.